Assalamu alaikum dear students. This is A2 Physics 9702, and in this lecture, which is basically the lecture number 2 of the series, or you can see the chapter is gravitational field, and the chapter number is 13. Chapter number 13. In this lecture, we will focus on these 2 points: Newton's law of universal gravitation and gravitational field strength. A little bit about the gravitational field strength we have already discussed in the first lecture, but here we will go in further details of the gravitational field strength. Before starting the Newton's law of universal gravitation, we have to discuss this very important term, which is point mass or point mass body. Remember one thing, that when we are considering bodies at a long distance, then we can consider the mass as a point mass. As far as the definition is concerned, we can define this in this way, that if a body covers a very long distance as compared to its size, then to study its motion, its size and dimensions can be neglected, and the object can be regarded as point mass or point mass object. यानी अगर हमारे पास एक ऑब्जेक्ट है और हम किसी दूर के पॉइंट से इसकी स्टडी कर रहे हैं, तो वो बॉडी एक बहुत ही स्मॉल मैस हमें नज़र आता है, एंड दैट्स वाई वी कैन कंसीडर दैट मैस एज अ पॉइंट मैस. लाइक हेयर वी हैव फ्यू एग्जांपल्स. सपोज़ हमारे पास अर्थ की अगर आप एक एग्जांपल लें और उसकी स्टडी कर रहे हैं, जो सन के अराउंड जो है वो मूव कर रही है, रिवॉल्व कर रही है, तो हमें अर्थ एक बहुत ही स्मॉल मैस नज़र आता है. सो इफ़ वी विल कंसीडर द डायमीटर ऑफ द अर्थ, then it will be very small as compared to its orbit around the sun. So when we study the revolution of the earth around the sun, we consider the earth as a point mass. I think it's clear that when we are considering the revolution of the earth around the sun, then the distance between the sun and the earth is a long distance as compared to the radius of the earth. So we can consider earth as a point mass. इसी तरीके से अगर मिसाल के तौर पर आप एक बोट को कंसीडर करें जो सी में मूव कर रही हो, तो एक लॉन्ग डिस्टेंस से, और एक लॉन्ग डिस्टेंस से मुराद है कि एक बहुत ऊंची जगह से अगर आप उसे देख रहे हो, लाइक सपोज इफ़ यू आर ऑब्जर्विंग इट फ्रॉम द एरोप्लेन, देन it will looks like a tiny mass and you cannot recognize it as a boat. It will look like a simple unit mass or tiny mass. So if we observe the motion of a boat in the sea from an aeroplane, the boat looks like a tiny mass or object, and we can consider that boat as a point mass. So this is very important, that from a very long distance this boat will look like only a simple point. Similarly, here if you have a person standing at a long distance from an observer, so you cannot see his or her hands or other parts of the body, but that person will looks like a point mass, very small tiny mass. So in that case you can say a person standing at a long distance from an observer looks like a point mass, that is we cannot see his or her hands, legs, etc., but the whole mass appears as a point mass. अब ये एक बड़ी इम्पॉर्टेंट चीज़ है कि इसकी इम्पोर्टेंस क्या है, पॉइंट मैस हमने क्यों कंसीडर किया या करना है. तो व्हाट इज़ द इम्पोर्टेंस ऑफ दिस टर्म, दिस इज़ वेरी इम्पॉर्टेंट. हियर एक्चुअली वी हैव टू कंसीडर दीज 2 पॉइंट्स. वी सपोज ऑल द mass of the body is concentrated at one point. यानी if suppose you are considering the earth, then you are considering the earth as a point mass. So what you will consider, that the whole mass of the earth is concentrated at the center. So this will actually help you to simplify the derivations or equations when you are going to drive the concepts of you can say gravitation. So just to simplify the derivation or equations, you are considering this concept of point mass. तो ये बहुत इंपॉर्टेंट बात है कि जब आप जो है वो ग्रेविटेशन की इक्वेशंस को ड्राइव कर रहे हों या डेरिवेशंस को आप लिख रहे हों, तो उस वक्त आपने पॉइंट मैस कंसीडर किया, और उसका जो यूज़ है, उसका जो फ़ायदा है वो ये है कि आपको जो है वो पूरे मैस को कंसीडर नहीं करना पड़ेगा. लाइक सपोज as I have given you the example here. So if suppose you have one body at this point and you have another body at this point, so what you have to consider, if you are not considering them as point masses, so you have to consider the radius of this body and radius of this body, and of course then the distance of these two bodies will not be only from the surfaces but from the center. आगे चल के हम ये भी देखेंगे कि इसकी क्या इंपॉर्टेंस है कि हम इसको सेंटर से मेजर करें, बट हेयर वी हैव टू कंसीडर दिस फ्रॉम द सेंटर. बट रिमेंबर वन थिंग दैट इफ़ यू आर कंसिडरिंग बॉडी एज अ पॉइंट मास, देन वो जो मुश्किल है वो नहीं होगी, और आप सिंपली ये कह सकते हैं कि हमारे पास एक पॉइंट ये है, दूसरा पॉइंट ये है, एंड वी आर गोइंग टू मेजर द डिस्टेंस बिटवीन दीज टू पॉइंट्स. सो वो जो मैंने अभी आपको बताया कि वो जो प्रॉब्लम है कि अगर आपके पास एक मैस ये है m1, सपोज एक m2 है, तो ये जो डिस्टेंस है r, वो आप सिंपली इसको एक टाइनी मैस या एक पॉइंट मैस कंसीडर करते हुए सिंपली ले सकते हैं. और सपोज़ कि अगर अर्थ की बात कर रहे हो तो अर्थ तो फिर भी आप एक स्फेरिकल बॉडी कंसीडर कर लेते हैं, तो रेडियस जो है वो चलें आपने कंसीडर कर लिया. बट इफ़ यू आर डीलिंग विद bodies like suppose we have this type of body and this type of body, so the distance will be difficult to determine कि इनके दरमियान में distance क्या है, कहाँ से distance लिया जाए. So if we are considering these bodies as point masses, तो हमारे पास ये फिर आसानी हो जाएगी कि हम distance को easily measure कर सकें. तो this will be much easier if you are considering this point mass. Because of this we are you can say dealing with these definitions, and this is one of the very important definition, the point mass. अब हम आगे चलते हैं, and basically we have to discuss the Newton's law of universal gravitation. What is Newton's law of universal gravitation? This is simply tell us that what is the force between two bodies and on what factors this force is depending. So here we have the statement for this law: every body in the universe attracts another body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So you have to consider between their centers concept, but if you will consider the point mass, then simply you can say every body in this universe attracts another body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So here every body will be a point mass. So this is something which is very important to understand, that if you are writing this statement, then of course you have to consider the centers. But as we have just mentioned that if you are considering the point mass, तो फिर वो difficulty आपको नहीं होगी. Simply आप कहेंगे कि every point mass in this universe attracts another point mass with a force which is directly proportional to the square of their masses and inversely proportional to the square of the distance between them. So you need not to mention between their centers. So ये बड़ी इंपॉर्टेंट चीज़ है, लेकिन ये हमारे पास जो है वो स्टेटमेंट है न्यूटन्स लॉ की, और इसके बेस पर फिर वी हैव टू ड्राइव सर्टन you can say equations and other laws, but this is the very fundamental law given by Newton, and this is termed as the Newton's law of universal gravitation. Now if we want to develop an equation with the help of this statement, so what we have here, like if you have force F, or F is the force of gravitation between two bodies of masses m1 and m2, then we can write, because we have already written here in the statement as a directly proportion to the product of their masses. So it's directly proportional to the product of their masses. And what is the distance between them? So as I had just mentioned here, that if you have two masses and the distance between their centers is r, so if you are not considering them as the point masses, of course you will consider the you can say centers, but if you are considering the point masses, then you need not to mention the distance between their centers, but simply you can say the distance between them. So square of the distance F is directly proportional to 1 over r square. अब यहाँ एक बहुत इम्पॉर्टेंट क्वेश्चन एक ये आता है कि भाई हमने ये कैसे कह दिया, ये जो हमारे पास दोनों स्टेटमेंट्स हैं, ये दोनों जो रिलेशंस हमने लिखी हैं, तो हाउ वी हैव रिडन दीज यू कैन से रिलेशंस, और हाउ वी हैव स्टडीड दिस लॉ, और हाउ द न्यूटन हैज़ स्टडीड दिस लॉ. सो दिस इज़ वेरी वेरी इंपॉर्टेंट क्वेश्चन. यानी आर स्क्वायर ही क्यों है, वाई वी आर डीलिंग विद आर स्क्वायर, वाई नॉट आर ओनली. तो दिस इज़ इम्पॉर्टेंट. तो याद रखिए कि हमारे पास यहाँ शायद कोर्स में तो उसका इतना तस्करा नहीं है, लेकिन कैवेंडिश एक साइंटिस्ट जो है वो था, एक फिजिसिस्ट था, और उसने एक्सपेरिमेंट्स किए और उसकी हेल्प से न्यूटन ने ये चीज़ें जो है वो देखी कि हमारे पास रिलेशन क्या बन रहा है, और कैवेंडिश की जो एक्सपेरिमेंट्स है उनसे ये चीज़ें एक्सपेरिमेंटली प्रूव्ड हैं. तो जब भी आप कोई रिलेशन लिखते हैं तो वो कहीं ना कहीं एक्सपेरिमेंट्स से वेरीफाई की जाती है. तो कैवेंडिश ने एक्सपेरिमेंट्स किए, या कैवेंडिश का जो अपरेटस था उससे वो एक्सपेरिमेंट हुए, और then we reached up to this point or this conclusion that force between 2 point masses or two bases will be directly proportional to the product of their masses and inversely proportional to the r square and distance between them. Now if you have these two relations 1 and 2, and of course both of these relations are related to the force, so for the force you can combine 1 and 2 relation, and something like this you will get that F is directly proportional to m1 m2 divided by r square. यहाँ ज़ाहिर है कि एक कांस्टेंट जो है वो हमें चाहिए होता है अगर हम एक इक्वेशन को डेवलप करना चाहते हैं किसी रिलेशन से. सो इफ़ यू वांट टू चेंज दिस रिलेशन इनटू एन इक्वेशन you need a constant, and again the same thing, the constant here we have determined is termed as the universal gravitation constant. This constant is termed as universal gravitational constant, and it is represented by capital G. The value which we have for this constant is 6.67 into 10 to the power minus 11, and of course the unit of this constant you can determine the units of these things, any force, masses, and the distance between the bodies. So Newton meter square per kg square will be or is the unit of your G, yani universal gravitation constant. You will see that in your data list you will have the value of this capital G, but I always recommend that if you can learn this by heart, then this will save your time. Otherwise you have to flip your pages back to see what is the value of capital G when you are going to calculate the values. So it's better that there's a sort of fundamental constants like G, you know, is 9.8 meter per second square. So you need not to go back to check that what is the value of the G. So I think same is the situation here. You need not to go back to check what is the value of capital G. So remember, this is very very important concept. And here we have this equation, and this is again a very fundamental equation. You have to use this equation number of times for further excuse me, further explanation. Then we have here the gravitational field strength. Before coming to the gravitational field strength, I just want to mention one thing here, that you know force is a vector quantity, and this equation is basically giving you the magnitude of that force. You know that of course the direction of the force will be, suppose if you have these two masses, then the direction of the force will be that any attraction if you have between two masses. So one body is attracting another body, say m1 is attracting m2 and m2 is attracting m1. So the force has a direction, and you can say that if suppose you are considering here F12, yani force of 1 onto body 2, so where this will be, this is the situation here, that here you have this force which is body 1 is applying on body 2, and here you have force F21, yani force of body 2 on body 1, and both of these forces are attractive forces. So ultimately you can say that we are just showing in this way, but basically instead of this you can draw the vectors the other way around, yani you can say that we are drawing the vectors in this way that they are attracting towards each other. So this will show you the attraction or attractive forces. So I think it's a better way to draw these vectors towards each other. So here we want to show the attraction, but previously which I have already drawn, this direction is just showing you that this force here is of the force of mass m1 on body 2, and here this force is the force of body 2 on body 1. But ultimately if you want to show the force of attraction, you can draw your vectors in this way as well. So this is how you will mention what is the direction of the force. But basically we are interested in the magnitude of the force. So this is the equation which is giving us the magnitude. So remember this point. Okay, now the gravitational field strength. Actually we have already defined the gravitational field strength in the previous lecture. If you have already gone through that lecture, if not, you kindly go through that lecture first and then come to this lecture. The force per unit mass acting on a body at a point of gravitational field is called gravitational field strength. Yani suppose here we are considering the earth, and we have actually we have already discussed this point, that if you have here, suppose you have the earth, then there will be a field around, there will be a field around, and this field will be the gravitational field. So what we are saying here, that in this gravitational field we have certain points, and at a particular point, suppose at point A, the force of attraction of the earth on the body, suppose the body is a small ball or another body of mass m, then you have m, suppose the mass of the earth, or you can write even me, showing you me, any mass of the earth. Then the force of attraction between these two of course is here, but this force of attraction, as we have already mentioned, that the r square is important. Yani if you are going away from the source, and away from the earth, so the gravitational field strength will be different at this point, different at this point, or at this point, or somewhere even into the earth. So this is what actually we want to know. As far as the definition is concerned, we have discussed this thing already, that if G is the gravitational field strength, then you can write the equation for gravitational field strength as F over m, then the force of the source, yani source is your earth in this case, and m is the mass over here at a distance. So this is something which is very important. We have discussed this point as well, that the unit of your G, small g, is Newton per kg. So unit of gravitational field strength is Newton per kg. So this is very, very important. And I have already mentioned this point as well, that due to this force, value of G from for the earth at a point is 9.8 Newton per kg, means that at a particular distance, the water distance, basically here you can say that at the surface of the earth, the value of the G is 9.8 Newton per kg. But what will happen? The acceleration due to this force will be 9.8 meter per second square. So be careful that here we have a situation that F is equal to mg. So if you are considering the force which is being applied by the earth, so simply you can say this is nothing but weight of the body, and if the mass is 1 kg and your acceleration due to gravity at the surface of the earth is 9.8 Newton per kg, so simply you can say that force is 9.8 Newton, which is nothing but weight of that body. So actually from the very you can say primary classes, we have been discussing this point, that mass is different and weight is a different quantity. Mass will remain the same everywhere, but weight will change. How it will change? Like suppose if the value of G for the moon or the surface of the moon is 1.9 or 1.6 Newton per kg, then the same 1 kg mass will give you another weight on the surface of the moon. And how you can determine? Simple multiply, like here we have 1 kg multiplied by 1.6 Newton per kg, and what you are getting 1.6 Newton. So you can see here that the weight of the same mass of 1 kg is different on the surface of the earth, or here we have another situation on the surface of the moon. So the surface of the earth it is 9.8 and the surface of the moon it is only 1.6. So because of the change of the value of the G, the weight will also change. So again the same thing here, and when you are going away from the center of the earth, the weight will decrease. But for the time being, of course, we are concentrating on G. So if G will change, the weight will change. So be careful of this fact that G is affecting the weight of the body. Mass of the body will remain the same everywhere. Now here we have another a simple situation, like suppose if you will consider this equation F over m for G, then from where this force is coming we don't know. Then we have not you can say introduce any body which is actually applying the force. So from where we can get this force, or what are the effect of or effects of the distance or the source mass on your value of G, we cannot mention with the help of this simple equation. G is equal to F over m. So what should we do? Here we are introducing the Newton's law of gravitation, or we are using Newton's law of gravitation. And like here suppose you have a situation which I have discussed here, that suppose m is the mass of the earth, radius of the earth is taken as r. Here you have a body of mass m at a distance of r dash suppose. Then what you can say, that here we have the radius of the ball. So what will be the situation? According to the Newton's law of gravitation, F is equal to capital G m1 m2 divided by r square. So what is the situation here? M1 is suppose mass of the earth, m2 is the mass of the body here at a distance of r. So if you want to mention this distance r or r dash, so this is basically r dash from the center of the earth to the center of this body. So how you can write this? Capital G m, yani capital M small m divided by re plus rm. Yani here you have this re, yani radius of the earth, you can even write re, and this r you can write rm. So I have mentioned here that this is the total distance. But as you can see here that the radius of the earth is very you can say large as compared to the radius of the moon. So here we have mentioned this point that as re is very large as compared to rm, so what you can say, that here we are neglecting this rm, and simply we can say that the distance between the earth and the body is nothing but re. So this is a little simplification. Or even if you will introduce the concept of the point mass, then you can avoid this confusion. As I have already mentioned, that if you will consider the point mass, and here you have one point mass which is your earth, and here you have another point mass which is the mass of the body. So simply you need not to mention anything, but simply you can say that the distance between these two is the distance over here. And basically this re you have to mention when you will consider this distance, and if you have a distance r dash, then of course the value will be different. But if you will consider the body at the surface of the earth, then you need not to actually mention this r dash. So if you will consider this r dash, a problem will be a little bit complicated, but when you will consider the distance from the center of the earth to center of the mass which is lying on the surface of the earth, so simply this will be the situation. And as I have already mentioned that Rm over here is very small, so you need not to mention anything but only this Re, but only this Re. So kindly follow this diagram for this description. We will come back to this diagram as well. But here, as I just mentioned, that if you are considering a body at the surface of the on the surface of the earth, then this will be the simple situation. So F is equal to capital G, capital M, small m Re square. Here, as we have already mentioned this point, that if you are considering the earth and the body is, or the mass is lying on the surface of the earth, then what will be the situation? The force of attraction of the earth on this mass is nothing but weight of this mass which we have just discussed. So you can write that this is nothing but force or weight which is mg. So if you will write here instead of your F, you can write mg. So you can say and see that the mass small m will cancel out from both sides, and here we will have the situation of the equation as small g is equal to capital G m over Re square. So this is very, very important. As we have just considered the body on the surface of the earth, then we have this situation that we are only considering this radius Re. So be careful. But here actually we have one very important thing to understand, that the capital G is a constant, capital M is a constant. So simply you can say that G is inversely proportional to Re square. So when this is Re square, it means that when you will go away from the center of the earth, like we have mentioned here, that if you have a body at a long distance r dash, suppose, so we can consider here as well that from the center of, from the surface of the earth, the body is going away from the earth. So what will happen? Of course, the value of G will be inversely affected. Yani if suppose you have a body which is at a distance of 2 Re, yani double of Re, here you have Re, somewhere here suppose you have the distance which is 2 Re. So what will be the value of G here? So simply you can say that this will be 1/4 of the initial value, because here when you will write like this is all constant, G and M are all constant, and over here you have Re square. So if you will write this way, that the distance is not here Re but R square, and what is R this time? Suppose we have this situation that R is given as double of Re, so 2 Re you can write here, be careful. And when you will take the square of this, what will be the situation? Constant, and here you have 4 Re square. So what is the situation here? I am writing on this left side, small g is equal to constant, but remember this thing that here we have actually changed the g from small g to another value, and we are mentioning this g as g dash. So if we have a g dash here, so simply what we can write is 2 Re square. But what is this thing? This is nothing but g. So what you can write? G divided by 4. So what you have observed, that when we have a distance of 2 Re, the value of G will be only 1/4 of initial value of G, yani the value of G on the surface of the earth. So this is very, very important. So simply what we can say, that when we are going away from the earth, as you can see another example, suppose if we have another distance somewhere here which is 3re, so ultimately what will happen, here we have another distance actually, so this distance if we are considering as 3re, then the square of that will give us 9re square, or you can say the value of g dash double dash you can take suppose for another position. So this is constant, and here we have 9re square, which is again telling us that this is g over 9. So in this way you can say that the value of g is inversely proportional to re square, and you know that if you have inversely proportion, so if you want to show this behavior on the graph, so if this point somewhere here you have 9.8, and what is the distance, then basically you are considering along x-axis the distance r, and you want to mention the effect of this distance r on the value of g. So what you are finding here, that the inverse relation is showing us this type of graph, a curve, and this curve shows that at each and every point what is happening, we have a decrease in the value. And how it is decreasing? With square of the distance. So this is what we have as far as the you can say value of g is concerned. And what we have just discussed, gravitational field strength at a distance from the surface of the earth. So if you are going away from the center of the earth, what is happening, or from the surface of the earth, what is happening, and outside the earth the relation is this way. This is the relation. So this is very, very important, and I hope you have understood this discussion. I have already mentioned all these things, so you can go through this discussion. Here we have already mentioned that if you have this situation, what will happen. So we have developed actually an equation here, that if you want to get the value of g dash, any a new value, so simply you can develop this type of equation, that g is equal to capital G M R E divided by R E square. But if you are considering an value of g dash at a long distance, then this will be the equation, and here you can see that we are dealing with r square only, and by dividing your equation 2 by 1 you are getting this relation. So g dash divided by g is equal to re square divided by r square, and here first of all you can see that the relation between these g's are inverse relation, and ultimately you can say and see that if we have this situation, that re is equal to r, or simply you can say that if r is equal to re, then g dash is nothing but g, yani whatever the distance you have here, this is nothing but the surface of the earth, so the g will nothing be but g dash. So this is the same situation, but when you will have a long distance, what will be the situation? You can consider that re if negligible, then you can simply say that the situation will becomes that g is equal to 0. So when the g will be 0, when you will be at a very long distance from the surface of the earth, and you can say that that will be an infinite point. Remember this thing, that infinite point means where the value of g becomes 0. So this is very, very important thing, where we do not have any effect of the gravitational field. So what will happen? G dash becomes 0. Then at a very long distance from the surface of the earth, you have a point where the value of g becomes 0. So you can say that here we do not have any gravitational field effect or any gravitational effect. Yani the body, if you have, suppose this is the earth, here you have, and you have a mass somewhere here. So if this distance is a very long distance, and you can neglect here the value of re, then what you will say, that this is the point where the value of the g becomes 0, yani there is no gravitational effect of the earth on this point, whether you are writing me or m. So this is very, very important thing to understand. Now here we have another very important concept, and this is the gravitational field is and inside the earth. अब अगर आप अंदर की तरफ जा रहे हैं अर्थ के तो क्या होगा, तो यहाँ पर हमें दो तीन चीज़ें कंसिडर करनी पड़ेंगी। पहली चीज़ तो यह है कि हमारे पास जो है वो एक तो अजम्पशन ये है कि द डेंसिटी ऑफ द अर्थ इज़ यूनिफॉर्म, and the second assumption is that the earth is a spherical body. Considering these two assumptions, we will move forward. If we are considering the earth as a complete sphere, then we know that volume of the earth we can write in this way, that V is equal to 4 over 3 pi r e cube, because volume of a spherical body is 4 over 3 r cube, so we can write this way the volume. Now we want to mention that what is the mass, any effective mass. This is very important. So as far as the mass is concerned and the density is concerned with the volume, density is given as the m divided by v, yani mass divided by volume. This is basically the density. So if we want to mention the density here, or in terms of density we want to mention the mass of the body here, so what will be the situation? M is equal to 4 over 3 pi r e cube rho. So this will be the situation of the mass, any effective mass. Now the thing is that if you are somewhere here, or the body for which you want to mention the gravitational field strength is somewhere here, then of course Re you have, the density you have, so total Re is involved, and simply you can say that the total mass is involved. But if you are somewhere here at point B, then what will be the situation? The effective mass is only this one now. This is the only effective mass. So what you can say, that when we are considering this effective mass here, then of course the m is given by this equation, m dash is equal to 4 over 3 pi r cube density rho. And again the same thing, why we are density? So the rho always, or in both the equations, because density of the earth we have considered as uniform or constant everywhere. So this is the new mass involved, because of which the earth will attract any body. Yani if you are considering a body somewhere here inside the earth, what will happen? This will be the mass. Now if we are dividing equation 2 by equation 1, what we are getting here, m dash divided by m is equal to r cube divided by r e cube. Or if we want to mention simply the m dash, this will be our equation, r cube divided by re cube into m. Remember this thing, again I am mentioning this point, that here you should know that this r is less than this re, and because of that this ratio will always be less than 1, because we are considering this situation now. This is complete re, but if we are somewhere here inside the earth, so this will be our r, and this r is always less than re. So be careful. So if the r is less than re, so you know that m dash will be less than m. Now coming to the point here, if we want to mention the value of g on the surface of the earth, which we have already mentioned, so this is nothing but g is equal to capital G m divided by re square, which we have already discussed. But when you will come to g dash, where inside the earth, so be careful, now you have the body on the surface of the earth, no, but inside the surface of the earth, or inside the earth. So only effective mass is this one, which we want to mention for the value of nu g, which is g dash. On this point, at this point A, if we have body, so the value is g, but for this point, suppose B, the value will be g dash. And here, as I have just mentioned, that the mass involved is only m dash, and of course the radius is only r. This is the radius r, and here you have radius RE. So I am repeatedly mentioning these things, so be careful. When you will use the equation for m dash, here you have m dash. So when you will use this value m dash here for new value of g or g dash, simply you can say, then you are getting this situation. Number of things will be cancelled out, or simply you can say will be taken as constant. Like here, when you will write gm over re square, you will get, and this is nothing but g. So here you have actually the situation, capital G, capital M, capital R, RE cube. But what you did actually, simply you have written this RE cube in this way, that if RE cube we have, we can write RE square into RE. So what was the purpose? The purpose was that this RE square with this capital G and M will lead us towards G, small g, and the remaining things like R and RE will give us the basic concept. So simply here what you can say and see, that the value of G dash is related with R and it is directly proportional. What does this mean? It means that when you will decrease this value of R, this value of R I am talking about, when you will decrease this value of R, what will happen? The value of this G dash will also decreases. So this is very, very important. And of course, on the other hand, G is directly proportional to RE, which we have already discussed. In this case, be careful. The relation is not coming as inverse relation as we have observed in case of your G, when you are considering your G at the surface of the earth. So G at the surface of the earth, you know, is given by the relation that G is inversely proportional to RE square. But when we are going into the earth, what we are finding, that new G dash is not coming as inverse of R, but it is directly proportional to R. So simply you can say that even if you don't want to write this G, don't write, just concentrate on this G, new value of G dash. So ultimately what you can simply say, that value of G, basically this G dash is nothing but G. So value of G in this case is directly proportional to the value or real value of, even you can write R. So what is happening in this case? As I have just mentioned, that when your R is equal to RE, so what will happen? When your R is equal to RE, so what will happen? You will have G dash equal to G, and you are again talking about the body on the surface of the earth. But when you are talking about the situation when R is equal to 0, if you are considering that the body has moved to the center of the earth, so when the body has moved to the center of the earth, what is new R? It becomes 0. So when it becomes 0, what you are finding, G dash is equal to 0. So this is very, very important concept. What we had observed already, what we have discussed already, that if we are considering the earth, then at a long distance from the surface of the earth, somewhere here suppose, we will have a point where G becomes 0. So this is the infinite point, you can say, where G becomes 0. But there is another situation. If we are going into the surface of the earth, then at the center of the earth we have again the value of G equal to 0. And actually this last equation is leading us towards a very, very important concept. What does this mean? So this means that if you do not have any mass involved, you do not have any value of G. The above discussion shows that when the body will be at the center of the earth, has no mass of the earth involved, thus the gravitational field strength becomes 0. So simply you can say the gravitational field strength of a body is due to its mass. So this is the most important conclusion. This is the most important conclusion, that basically the gravitational field or gravitational force is because of the mass. If there is no mass, there will be no gravitational field or gravitational force. So simply you can say that in this universe, whenever a mass will be created, that mass will dent the you can say environment, and that dent is basically giving us the concept of the gravitational field. So this is very important concept, and I just want to mention here that suppose if you have somewhere you have a sort of tent tied with or between two poles. Here you have two poles suppose, and in between these two poles you have a tent here. Then what will happen? If you will throw a heavy body like say a football or something like this, or even a stone, what will happen? The tent will have a sort of slack situation. So basically what has happened, when you have a stone here or a ball here, then this stone, what is getting? A sort of dent, and this dent is basically a gravitational field, or it acts like a gravitational field. Yani if suppose you are putting say a ball somewhere here, what will happen? The ball will move towards that depression. The ball will move towards that depression, another ball I am talking about. But if suppose you are putting the same ball somewhere here, or at this point the ball is not moving anywhere, it means that this area which I am just mentioning here, this area or this depression is acting like a field, gravitational field. So same is the case here. If you have earth, then actually the earth has created a sort of dent in the environment. So simply you can say that everything which you are putting in the gravitational field of the earth, like suppose here we have this type of well, and if you have this well, this well is because of the earth, mass of the earth. So if you are putting anything here, this body is moving towards the hell or bottom of the hell, so you can say that the body is falling into the gravitational field, and of course it is towards the center of the earth. So this is very important concept, and that's why this is very important to understand that if we are going into the earth, actually the value of G is decreasing. The misconcept is that if we are going into the earth, the value of G will increase, because we feel that the gravitational force is coming from the center. But remember this thing, that gravitational force is not coming from the center, but gravitational force is because of the mass of the body, in this case mass of the earth. So this is very important, that here if we have complete mass of the earth, then of course we will have complete force of gravity due to the earth. But when we will go into the earth, the mass will decrease, and ultimately the gravitational field strength, yani value of small g, will decrease. As far as the relation is concerned, I have already mentioned that this is directly proportional to each other. It means that when you will draw a graph, like suppose here we have discussed somewhere here we have discussed this graph. So this graph shows that when you will talk about the you can say effect of the distance from the center of the earth, like suppose here you have the center of the earth and this is the distance which is RE. So at RE the value of G is 9.8, and as we have already discussed that when we will go away from the surface of the earth, this value will decrease in this way because it's inversely proportional. But here when you will go into the earth, you will have a direct relation, and you will have a straight line which is showing you that you have a value of g, and at value of at the center of the earth you will have 0. Any simple thing is that when you are increasing the distance from the center to the value of re, then you can simply say that the value of your g is increasing directly, yani directly proportion to each other. And at the center of the earth, what you are showing, simple thing is that you are showing here that when we are at the center of the earth, the value of g is nothing but 0. So this is very, very important. So at 0 distance, value of g is 0. So apart from 0 to the surface of the earth is re, the radius is re, of course radius of the earth. So inside the earth, the relation between g and re is directly proportional, and we are showing by this line or curve. On the other hand, as I have already mentioned, that when you are going outside, the distance increasing and the value of g is decreasing, and this is the relation here you have. So I hope you have understood this discussion, and if you have any problems, kindly ask me in your comments. And if you are new on my channel, subscribe this channel and like and share this lecture, and I think this will be beneficial for other students. So I think you better share this with your friends. Press the bell icon if you are new on the channel, subscribe, and inshallah in the coming lectures we will be continue with this chapter of gravitation. And if you will follow my lectures, inshallah you will not feel difficulty to cover the course, as I have been telling you before as well. And of course after completing these chapters, we will go for their past papers as well. So with this hope that you have understood today's lecture. Till the next lecture, Allah Hafiz, take care.